Okay, hi everybody. Going to start with our review for the final exam going backwards all the way to January, and then hopefully construct this in a way where you can be successful. So this sheet represents the note sheet. You should get your own piece of paper out and maybe head your page, so you can write down the important pieces of information per chapter, and as you write it down, the process of writing this stuff down gives you a better chance to memorize the things that you need to remember for our final exam next week or the following week for those that are in my third hour. All right, so this is the note sheets, and then I'm going to switch to the worksheet that I handed out to you, which is this. I think the first set of questions aren't really note sheet per se, but I think for circles you should be aware of these terms, and I think at this point you should stop the movie and do the best you can with labeling these parts through memory. Because most of this stuff is stuff that you did in grade school. My fourth grade daughter went through all the parts of a circle this year, saw worksheets like it, so hopefully you can recall that plus what we did this year. So stop the movie, try to do the matching in the first 7, and then we'll go from there. Whoops, sorry, that's a good start. All right, so again, stop and go. Point is you want to figure this stuff out yourself, and then just going to fly through it real fast. EA is labeled as a line, and it crosses the circle twice. That, by definition, was a secant. Can you say secant? All right, good. 2, AF, that edge of the center, or to the center. Holy cow. This is a segment from the center to a point on the circle. Spent way too much time in it. Everyone should know that that is a chord. Oh, wait, I screwed that up. Oh, my goodness. That's a radius. My bad, dogs. Okay, a little early in the morning. A little discombobulating morning at that. So, all right, so obviously AF is a radius. Hopefully I got the rest of these right. Ay caramba. All right, so hopefully you have an A here. Ay caramba. I misaligned my letters. F is the center of a circle, so F is a center. Maybe I looked at this wrong here, but number 4, DA, hopefully we have that as a diameter. Thank goodness. Okay, so D to A, and it's labeled as a segment, endpoints on the center passing through the circle center. So that's a diameter. All right, 5, point C. That is a point of tangency. Remember, a point of tangency is where a tangent line only crosses a circle once. That's the point where it crosses the circle once. So that's why what that is. 6, AE is B. So here's AE, and it's labeled as a segment. So that means it stops here and here. So that makes it a chord. All right. Oh boy. It's different than number 1. Number 1, it keeps going through forever and ever with the arrows. So that's why number 1 is a secant line. And then number 7, AB. Where is it at? Okay, AB is another tangent line. All right. So that's what we got there. All right. Good enough. Now go to your notes. And I'm just going to switch right to it. Okay. The next concepts on our worksheet. Really, I can label with these 1, 2 concepts right here. First of all, remember what a central angle is. A central angle has a vertex at the center, and its endpoints hit the circle itself. So we'll call this circle C. We'll call these AB. First of all, naming an angle, which is something that is going to be on the final as far as how the questions are going to be lined. You got to know how angles are named. So remember that the vertex is in the middle of the name. I could say angle ACB or BCA. But the thing you need to remember is this measure right here of the angle is equal to the measure of the arc. All right, so if this was 40 degrees here, then this is 40 degrees. Remember, a full circle is 360. All right, so this angle from here to here is 360 degrees. This arc measure is 360 degrees. All right, so that's the correlation between a central angle and the arc measures, if you recall that. Whereas an inscribed angle, just imagine if I took this point right here and pulled it all the way back like a rubber band to here. I think everyone and their mother, brother, sister, parent, or guardian would know that the angle measure closes when you snap this back. So if I put this back to here, I think everyone can see that this angle measure is smaller than this one. All right, but I'm going to put that over on the other drawing. By how much? By half. Okay, so if this arc measure is 40 degrees like that last picture, then this inscribed angle is only 20 degrees, half of that measure. Okay, so again, I'm not going to name this angle. You got to know how angles are named. That's basic geometry. So an inscribed angle equals half of its intercepted arc measure. All right, just really scratching this down. This is review, so it should be stuff that you recall. All right, so now I'm going to go to the worksheet and only do a couple that pertain to this little section here. Went crazy on the bottom half, going back and forth on all this stuff. But this is all about central angles. You can see every angle touches the center here. So these are arc measure questions based off of this central angle given. So if this is 87 degrees, what's this measure? Correct if you said 87. This one is 68. What's this measure then? 68. Okay, so you got to identify a central compared to an inscribed and the difference. This is called a diameter as you read this question. So a diameter cuts a circle in perfect halves. So this is 180 right here, and I'm going to stop the movie for a second. Okay, so I had to stop the movie because I had to open up my calculator. All right, so to get this little other angle measure here, you do 180 minus because half a circle is 180 degrees. So if this is 25 degrees, then this is 25 degrees. And then so on and so on and so forth. I'm not going to fill out all these. This is stuff you should be able to do. But remember, 3-letter arc measures means major arcs. Sometimes it also means semicircle. Sometimes they do that, and actually they do a lot. So these measures should be 180 or greater, these answers. And basically what you'd have to do is add. Very simple. One more thing, remember what kind of angles these are. Line, line, or segment, segment. These angles are equal because they're vertical. All right, so you should be able to get that last measure of the central angle and then label the other arcs and then have no problem answering these questions. 2-letter arcs are the direct less than 180 arc measures. So these should be less than 180. This one, this one, this one. The other 3 should be 180 or greater. All right. You do that, and then we'll wait for the key when we check that the next day. All right, I'm not doing all of these. Again, the whole purpose of this is I'll show a couple, and then you do your own thing. Love 15, I'm going to leave that for you because it identifies the difference between X that cuts this arc and Y that cuts this arc. Basically, it's the two things I just taught you. But first things first, and actually we could find out more. I could find out what is this arc measure here because of how this is aligned. Somebody throw that at you just for extra giggles. But first things first, this is an inscribed angle. So an inscribed angle equals half of the arc that it cuts. So this is simply what you would do if this ended up being a final exam question. This should be 38 degrees, so that's what X is. Now the reason I threw this other one here is this is a diameter. So if this is 76 degrees, even though it may not look like it, this should be the rest of 180 degrees because a diameter cuts a circle in half. So just adding that real quick, you could have a whole bunch of different type of questions based off of these basic concepts. Oh boy, can't even type correctly. All right, and then that's just 104 degrees. That would be the arc measure from here to here. You do this one. It should be very easy to figure out what the difference and that one. These are actually very related to the concepts up there of central or inscribed. As a matter of fact, these are all inscribed examples. So I'm going to go ahead and do this one and then talk about this one real quick, and then you could do 18. These are all inscribed angles. So what you need to do is have the ability to see that this angle cuts this arc. Okay, I think that was a real big problem back in the day, just identifying what angle, or the angle that intercepts what arc. So angle X, inscribed angle, intercepts 90 degrees. So that makes this 45. So angle X, half. Again, it's you're either going to memorize it or you're not. It's pretty standard. Just memorization is the key. Z can be found. Probably should use red. It pops a little bit more. So hopefully that hit. Didn't seem like it. Oh, brother. There we go. All right, so Z intercepts, because Z, this is the vertex right here, and then the other 2 points are here, intercepts this angle. So Z is equal to half 170. And just because my brain's early in the morning, just punching the buttons so I make sure I don't make a mistake. All right, there's 2 ways you can go about this now. And I might as well cover one of them because you're going to need to know this. 3 angles in a triangle add up to 180 degrees. So really what that means is Y, the last angle that I have, is 180 minus these other 2 angles in the triangle. So I'll do that first, then I'll give you the other concept that you should know. 45 minus 85. Okay, and tray, so Y should equal 50. Lo and behold, another thing you got to know is that an arc measure, a complete arc measure of a full circle, is 360. So watch what happens here. 360 minus 170 minus 90. Take a wild guess what you're going to get. If you said a hundo, then you understand both concepts together. Okay, Y cuts this arc. This arc is 100 degrees by 360, these adding up to 360. And Y is half the measure of that. So there you go. All right, you do this one, very similar concept, number 18. You should have no problem with it. The only reason I'm going to cover this one is how do you find X? Well, I'm only going to do that. You find Y. Just figure out the relationship of who you got here. But this is a diameter. All right, which is actually part of a radius, or radius is part of a diameter. And this is a tangent line. So quite honestly, there was a theorem that we told you about that a radius is perpendicular to a tangent line at its point of tangency. So that's one reason X is equal to 90 degrees. The other reason is this is sort of like an inscribed angle, where its measure is equal to half the arc that it cuts. And this could be considered the arc that it cuts. So 2 reasons why X is 90 degrees. That's all I got to say about that. You find Y, and you do the other ones. And we'll take a little break here. Okay, resuming, when I ordered these yesterday, I kind of put them out of order. No big deal. You put them in the way you want to do it, okay? We just had questions where the triangles were inscribed in a circle. But the reason I wanted to put another one, and I forgot why I put 2 here. I'll have to remember that for a second. Sorry. But what if I had a triangle like this? Little different scenario. Okay. So first things first, the triangle, actually one of the sides represents a diameter. I know I was going to do this, and I'm not doing it anymore. I already covered it with the last 2 questions that I showed on your worksheet there. Those are triangles inscribed in a circle, so full circle is 360. 3 angles in a triangle add up to 180, and we described those relationships. So same thing's happening here, but what if one of the sides goes through the diameter? Well, I don't really need to cover this as a special scenario. Since this is a diameter, this measure right here is 180 degrees. All right? Since that's 180 degrees and this angle right here intersects